So for the Math 3 Week 2 homework, we've got 2 problems that are asking about an experiment. So I'm going to do problem number 1 and answer these questions, and then your job is to do problem number 2, okay? So surgery patients are often cold because the operating room is kept cool and the body's temperature regulation is disturbed by anesthetics. Will warming patients to maintain normal body temperature reduce infections after surgery? In one study, patients undergoing colon surgery received intravenous fluids from a warming machine and were covered with a blanket through which air circulated. For some patients, the fluid and the air were warmed. For others, they were not. The patients received identical treatments in all other respects. So this is a lot of reading right now, and sometimes it's hard to piece out what we care about. But if you notice here in the questions, what are the treatments of this experiment? What are the subjects? And what is the response variable? That will help us go back through and read it in a way that helps us understand. So the treatments, remember the treatments are the 2 things that they're comparing. The subjects are who is being experimented on, who or what, and the response variable is how they are measuring the outcome, right? So let's look again and try to find the answers to those questions. So surgery patients are cold, so they're kind of, this sentence right here just gives us a background of why they might want to ask this question. Will warming patients to maintain normal body temperature reduce infections, right? So again, this is the question they're trying to answer, but that doesn't give us treatment subjects or response variable. So the one study, that's where the meat of the answers are going to be. Patients that are undergoing this particular surgery, and that's not important, right? So the important part, so they received fluids from a warming machine, which were covered with a blanket through which air circulated. For some patients, the fluid and the air were warmed. For others, they were not. So the treatments, remember, treatments are what's compared warmed air versus not, right? What are the subjects? The subjects are the people who are being experimented on, right? The patients, right? The patients undergoing colon surgery. So patients undergoing colon surgery are the people that we're working on. And the response variable, this is how are you going to measure your outcomes? Now, there's not exactly, they didn't exactly say, so let's go back and see what they're looking for. They're looking to see if warming patients to maintain normal body temperature, reduce infections after surgery. So what they're going to be looking for to see, they want to see what the, remember, outcome is going to be. They're looking for the outcome to be about reducing infections after surgery. So they're going to need to measure that. So you make up the measure, but here my guess is it's going to be the number of infections post-surgery, right? That is something they can measure as an outcome. Now, the last question, does it have all 3 characteristics of a well-designed experiment? Does it have a control group? Yes, that's right here with the treatments, right? Is it randomized, and are there sufficient subjects? We don't know the answer to those 2, right? So we can say it has a control group, right? But we're not sure. We don't have enough information to tell if it's randomized. We don't have enough information to tell if there's sufficient people in this study. So that's what I would write for D. So you write that. Now you do number 2. And then I'm going to go ahead in this video, since 3 is about experiments. It says make up an experiment and make sure it demonstrates 3 characteristics of a well-designed experiment. So here you're going to need to make sure it includes that. So I'm going to make mine up. You need to make up a different one that's not mine. So I'm going to make one up, and I want to know if students do better on homework when I provide study videos than when I don't. So what I'm going to do is I'm going to come up with an experiment, right, that decides that, right? So I'm going to say, okay, I have This is a little bit difficult because how am I going to know if it's random or not? So I can say, okay, I'm going to give my class, I'm going to make study videos. So my treatments are going to, so my question is, so you heard my question, so you need to be able to write a question. My question is, do students do better with study videos instead of no study videos, right? So my treatments are study videos or no study videos, right? My subjects are going to be my classroom students, right? So, and I have 30 some classroom students, so that covers sufficient number. It covers control group, right? Now I just have to decide about randomization. Now I could say, well, one test I'm gonna do study videos and another one I'm not. That doesn't quite get at randomization, but that's not imperfect. Another way I could do it is I could ask students, I could say, okay, I could pick names out of a hat and say, okay, you guys are not allowed to use study videos and not give you guys access. I'm going to email them. And I only email students that come up in the random number generator that came out. If I take the students' names, I sort them into like 2 piles. This pile over here gets those study videos and emails. This pile over here doesn't. That would be the best kind of randomization. Now, I will say that there are problems of ethics. It's not really fair to give some students study videos and not other students. So this is where ethics sometimes get in the way of doing a really perfect study. So a perfect experiment would randomize and only give study videos to people whose names were drawn. But ethically, I would never do that to you as a teacher. So make sure that whatever experiment you design, it shows that it has a control group, it shows that it's got a sufficient number of subjects, and it shows that it's got randomization. Design, how are you going to create it randomly?